भुजंग पर्यात छंद नमो सर्वमान्य समस्ति निधान नमो देव देवे अपेक्षी अपेवे salutation to thee o universally honored lord salutation to thee o the treasure lord salutation to thee o the greatest lord salutation to thee o garbless lord unit 6 part 4 applications of lingam diagram. Applications of a lingam diagram. There are mainly three applications here will be discussed. First one is the extraction of copper from cuprous oxide, that is copper 1 oxide. Extraction of zinc from zinc oxide. Extraction of iron from its oxides. Mainly three applications we are going to discuss here. First one is the extraction of copper from cuprous oxide, that is copper 1 oxide. In a lingam diagram, the Cu2 line is almost at the top, so it is quite easy to reduce oxides or of copper directly to metal by heating with coke. However, most of the ores are sulfide and may also contain iron. The sulfide ore are roasted, melted to give oxide. First one we will the roasting of the ore to convert sulfide ore into the oxide ore. Equation is given. The oxide can then be easily reduced to metallic copper using coke. The cuprous oxide Cu2O plus coke changing into copper and carbon monoxide. Practically, in actual process, the ore is heated in reverberatory furnace after mixing with silica. In furnace, iron oxide slags off as iron silicate as shown by the equation, and copper is produced in the form of copper mati. This contains Cu2S and Fes still as impurities. Copper mati is then charged into silica line converter. Some silica is also added and a hot air blast is blown to convert the remaining Fes2 into FeO and Cu2S into Cu2O to the metallic copper. Following equations take place. There are four equations as shown here. Note the solidified copper obtained has blistered appearance due to the evolution of SO2, and so it is called a blistered copper. Next one is the extraction of zinc from zinc oxide. The reduction of zinc oxide is done using coke. The temperature in this case is 873 Kelvin, higher than that in case of copper. This choice of reducing agent here also is due to the application of Lingam diagram. Is by the application of Lingam diagram. For the purpose of heating, the oxide is made into briquettes with coke and clay. ZnO plus C changing into Zn plus CO. The metal is distilled off and collected by rapid chilling. Now C1 is the last one application of Lingam diagram is the extraction of iron from its oxides. Oxides of iron after concentration through calcination roasting are mixed with the limestone and coke and fed into blast furnace from the top. Here the oxide is reduced to the metal. Thermodynamics help us to understand coke reduces the oxide and why this furnace is chosen. All this choice of reducing agent, choice of temperature, all these are things coming by the applications of Lingam diagram. Following reactions takes place in the blast furnace. Following 9 reactions are given. All are important, asked in the examination many times. Write the equation involved in the extraction of iron from its oxides. During the extraction of iron, some things we will have to note. First one is the limestone is decomposed to CaO, which removes silicate impurity of the ore as slag. The slag is molten state and separate out from iron CaO, SiO2. Now CaSiO3 will form. It will be fusible, lighter, and maybe will be skimmed off. And second note is the iron obtained from blast furnace contain about 4% carbon and many impurities in smaller amounts such as sulfur, phosphorus, silicon, manganese. This is known as pig iron and cast into variety of shapes. It is the impurest form of the iron. Third one is the cast iron. Is different from pig iron and is made by melting pig iron with scrap iron and coke using hot air blast. It has slightly lower carbon content, about 3%, and is extremely hard and brittle. Third one is the wrought iron or malleable iron is the purest form of commercial iron and is prepared from cast iron by oxidizing impurity in a laboratory furnace lined with hematite. This hematite oxidizes carbon to carbon monoxide Fe2O3 plus 3C changing Fe giving to Fe and CO. Therefore, this question is important. What are three forms of iron? That is pig iron, wrought iron, and cast iron. Which is the purest form? That is wrought iron. Which is the purest form? It is the pig iron. All these three forms of iron has the different content of carbon. They differ in the content of carbon. Now, limestone is added as a flux and sulfur, silicon, phosphorus are oxidized and passed into slag. The metal is removed and freed from slag by passing through rollers. It is all about the applications of a Lingam diagram. Three applications we have already studied. Now next one is the electrochemical principles of metallurgy. That how we can get metal from the solution. In the reduction of molten metal salt, electrolysis is done. Such methods are based on the electrochemical principles which could be understood through the equation delta G naught equal to minus NF E naught, where N is the number of electrons and E naught is the electrode potential of the redox couple formed in the system. More reactive metals have large negative values of electrode potential, so their reduction is difficult. If the differences of two E naught values corresponds to a positive E naught and consequently negative delta G naught in the above equation, then less reactive metal will come out of the solution and the more reactive metal will go into the solution. For example, Cu is aqueous form and Fe is solid. Fe goes into the solution now and copper is solidifies. Cu solidify and Fe goes into solution as aqueous form. Now note number 1, in simple electrolysis the Mn positive ions are discharged as negative electrodes cathode and deposited here. Precautions are taken considering the reactivity of the metal produced and the suitable material are used as electrodes. Sometimes a flux is added for making the molten mass more conducting. These three notes must be kept in mind. Now, metallurgy of aluminium, very important. In the metallurgy of aluminium, purified Al2O3 is mixed with Na3AlF6 or CaF3, which lower the melting point of the mix and brings conductivity. Is the question of NCERT. Why Na3AlF6 or CaF3 are added to Al2O3? The answer is to decrease the melting point and to increase the conductivity, electrical conductivity. The fused matrix is electrolyzed. Steel cathode and graphite anode are used. The graphite anode is useful here for the reduction to the metal. The overall reaction may be taken as Al2O3 carbon changing into Al and CO2. This process of electrolysis is widely known as Hall process. Now, the electrolysis of the molten mass is carried out in an electrolytic cell using carbon electrodes. The oxygen liberated at the cathode react with the carbon of anode producing CO and CO2. This way, for each 1 kg of aluminium produced, about 0.5 kg of carbon anode is burnt away. Therefore, we will have to change anode from time to time. The electrolytic reactions are cathode Al3 positive plus 3E negative changing into aluminium, at anode C plus O2 negative changing into CO plus 2 negative 2E negative, and C plus 2O2 negative changing into CO2 plus for electrons. Oxidation reduction, next process. Oxidation is used for non-metal. A very common example of extraction based on oxidation is the oxidation of chlorine from brine. Chlorine is abundant in seawater as common salt. Therefore, Cl negative is in aqueous form. In water, H2 is liquid. We will get 2OH negative as aqueous, H2 gas, Cl2. The delta G naught for this reaction is 422 kilojoule. Thus, Cl2 is obtained by electrolysis, giving out H2 and aqueous NaOH as byproducts. Now, extraction of gold and silver. Extraction of gold and silver involve leaching of the metal with Cn negative and HCN. This is also an oxidation reaction, Ag changing into Ag positive, Au changing into Au positive. The metal is later recovered by displacement reaction. The equations are shown. Suppose we have some gold in some mixture with impurities, then gold is then the in ore we add Cn negative and water, oxygen. It dissolve only gold. It does not react with the impurities. Therefore, gold will form the complex with cyanide 4 AuCN twice, and it dissolve while impurity remains in the solid form. It is filtered away. Gold come into another vessel, and impurities are left behind. Therefore, now this complex, gold in the form of complex, is obtained by displacement reaction. Zinc will be added to this solution, and zinc displaces gold, and zinc will go into the solution, and gold will solidify as shown by the equation. In this reaction, zinc acts as the reducing agent. Thank you for attending the lecture.